The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Hello, good afternoon, everybody. Thank you for coming. This is session 3 of 3 for the lubrication. With me, my name is Buck McVaney. I'm the district manager for the Southern Plains area for Industrial Kiln and Dryer. With me is Carl.
Good afternoon, everyone.
We've also got Bailey helping us with our technical stuff, and we've got Jason Mersman, who's with us at our training facility. He's going to be giving us some live action shots as we go through this. If you've got any questions, we got Jason set up. As we go through this, we hope it's very interactive. We hope to have you guys involved in asking questions as we go through this, and hopefully you have some questions that we can answer for you. Jason, walk us through how we can get a question.
So first off, for everybody, if you can't see Carl and Buck up on the screen now, make sure you turn it on to where you can see everybody's web cameras. Not only will the guys be talking about stuff, but we'll also be showing some stuff here at the shop with our test unit. But right now we want to go over, we know a lot of people have problems getting to the questions and answers. If you look at your menu over here, you should have a drop down with questions on it. If you click on that drop down, it'll open up the box, and then you can actually put in your questions here and send them privately to us individually or as a whole group. And once you send those in, Bailey or myself will be kind of watching for those to either put the question out to the guys, or we'll answer it privately and get back with you on a follow-up.
Yeah, thank you, Jason. So, I mean, we want to answer the questions as we go if we can. Obviously, if they're more complex or very detailed, we'll definitely follow up with you when we get finished or very, very quickly after this. So session 3, we're going to talk lubrication, and specifically we're going to talk about tire bore, tire ID. We're going to talk about our support rollers, thrust rollers, bearings, and some of the oil soak and accessories. Carl's in the driver's seat, so I'm going to hand off to Carl.
Copy that. Thank you, Buck. Thank you, everybody, for showing up today and just to learn a little bit more about what we have to offer. We've got quite a bit of information to go through today, so we'll try and breeze through this. But if there's anything that stops you got questions, feel free to ask, or you can always contact us after the presentation as well. So if you can't figure it out, no problem. Feel free to reach out to your IKD representative or myself, and that contact information will be shared at the end of the presentation as well. So anyway, with that being said, I'm gonna go to the next slide. And before we jump into the tire ID, we'll go to the outside here. So the rotary dryer and kiln components, tire phase, just a quick review. To our left, there's tire damage due to poor lubrication. We've got an example of tire cracking when this was kind of an improperly added little grease fitting, if you will, to add lubricant. So, and now you can see the crack in the tire itself. We're trying to avoid all these things and make these tires last as long as possible. And we find it in the industry commonly used on the graphite blocks. They do glaze over, so they stop applying lubricant. They do get washed off in the rain fairly easy. So this is some of the evidence that you see in the middle picture. And then the new moly block that we've developed does not glaze over and doesn't wash off in the rain. So this coating is pretty robust. It is not thick. It's only 0.5 micron on each surface. So when you put the two together, there's only 1 micron of protection. So it kind of demonstrates the capabilities of this. So a pretty awesome product. But that's just one of our many solutions that we have to offer. So let's go ahead and move on to the tire ID. So today's discussion and presentation, we're going to go through that. the support rollers, the thrust rollers, as well as some of the bearing applications, and that'll be for both oil as well as grease. We'll go into how much grease to apply, where to apply, and all this kind of good stuff too. So hopefully this will be an informative type of discussion today. We all know what these components are. We've seen them, we work around them all the time, the slipper pads, the kennel shell, or the skin, but you lubricate the tire both on the face of it as well as on the side. So just to give you some idea, but you know, we want to prevent the shell from damage and also the tire from cracking. Those are the big key things. The challenges are it heats up. You got a lot of heat that's going through there. I know dryers don't operate at the same temperature as a kiln, but there's still high heat. You still have expansion of metal that you're trying to protect from. And this shell and slipper pads allow that little bit of slip during expansion and stuff like that. So that's what we want. We want to lubricate. It's a small space, but we got a product that'll wick right in there and lubricate it.
Yeah.
Typically, what you'll find. Yeah, go ahead.
Well, I was just going to say, to follow up on when you know, there's some different things that what we're saying. Slipper pads, people commonly refer to as the tire support pad, filler bars.
Yeah.
When we talk about slip, we're really, you know, most people commonly call that creep. And so when we've got those two components rubbing against each other, you know, causing wear, this will help to prolong the life of those components. Obviously, most of us are very, very aware of lubricating the tire face and the support rollers, but not always the tire bore where we've got that creep. So, and there's I'm going to pause there because sometimes the thought is that if I lubricate the bore of the tire, or the idea of the tire, that I'm going to create more creep, which is not the case. The tire creep is relative to the thermal expansion of the unit, right? So when you have creep to help reduce the amount of wear that's happening, that's when you want to lubricate. You want to try to lubricate as often as you can, or as much as you can. Jason, in his hand, he's got a spray bottle there, you know, just kind of demonstrating the way that this, and we'll get to it. I think Carl's going to obviously talk more about it, but just one of the ways that the tire ID or the bore lubricant can be applied very easily.
Yeah, and this is one of the safe methods. It is a water-based type of gel, and the graphite synthetic particles are only 1 to 2 microns in size. So I know Jason's getting up and close to it, but if you put some pressure in that little spray canister, you can step away and spray and hit that thing from about 3 to 4 feet away. So you're not cooking next to the shell, so that'll help out. But yeah, excellent. Good job, Jason.
Vanna White.
So, all right. Good points, Buck. I appreciate you pointing those out. All right. So the back of the tire, this is what we're talking about, lubricating, so the ID. So a lot of times you'll run into easy bars or graphite blocks. But if the graphite blocks are being used, you know, they usually cut these things down to size, or they're little spares, and they'll slip those in between the pads. Unfortunately, there's not a whole lot of weight to these things, so they don't get a whole lot of surface energy or friction to actually lubricate on the inside. So they're not exactly the optimal, effective way of doing it, but you know, for what we've got, that might be the only solution available to you. But now we've got the water-based gel that we sell in the concentrate. You can dilute this down into 10%, meaning 9 parts water and 1 part of the concentrate. And this will give you a 10% solution. And you can spray that. It'll actually wick in. You'll see a little bit of steam come off, but not much. But it's just going to leave a nice, solid, dark gray coating there. And what's nice about it, you're going to actually spray both sides of the tire, so that way it'll get within there and it'll wick across the entire way. So watch your angles or when you apply it, but if you got enough pressure in that spray canister, not only can you keep a safe distance away, but you can also allow the product to wick in there even further. So The one key thing that we want to stress on, sometimes you'll run into where you've got, you can lubricate the sides of the tire. So the retaining blocks are there. Those actually create friction and wear as well. So you can actually do the side of the tire as well. So when you're applying this, I usually aim for the slipper pad area and go just a little bit, about halfway up the tire. If your tire is really rusty and you want it to look really good, you can coat the entire side of the tire as well. Just because it's not going to be used or see a whole lot of friction, at least the coating will, provide some kind of a rust preventative measure. So if that helps out.
You mentioned when we first started on our first slide, we had talked about the typical or the old graphite blocks. From a maintenance standpoint, where we're at, us maintenance guys that are trying to, keep these things well lubricated, those graphite blocks will glaze over, and they stop lubricating at that point. Kind of the same example when it was using the graphite blocks between the pads, filler bars, slipper pads, whatever you want to call them. Eventually, they'll do the same thing. They'll glaze over and they'll stop lubricating as well at that point too. So the other option is obviously this, or the potential using the smaller graphite blocks, or the ones that Carl has mentioned in there as well.
Yeah. And just to give you guys an idea, the reason for the 52 in the product name, there's 52 weeks in a year, and this product is usually applied once a week to the tire where the slipper pads are. So go around a full revolution. If you're just now getting used to using it, you might want to do 2 revolutions until you see how it works and see how good of a coating it presents. And then after that, you can do 1 revolution per side should be sufficient with a 10% dilution rate is what we found. So works really well. It's a lower cost and probably effective and also a safer way of applying it, to address that lubrication need.
Well, anybody that uses these parts knows how nasty those could be. So much cleaner too.
Yes. Or the easy bars get really stinky at the hot end is what I've been told. I try to avoid those situations. So anyway, tire rollers and the trunnion bearings. These are some of these heavily loaded. They're either protected by grease or oil only. Oil, and the others still have the old oil with the water circulation to help, they use the water to help remove a lot of the heat. But keep in mind, these bearings are frequently found in outdoors in the elements, so they're exposed to high humidity, whatever the humidity is there in the air, as well as dusty environments. So if your trunnion bearing application doesn't have a desiccant breather, sometimes if you've got the heat shield, utilize that heat shield and put a desiccant breather in that application. That'll help remove a lot of the humidity in the air that goes into the application, as well as the dust particles. All right. So depending on the type of roller, so like we said, grease lubricated bearings. On your product data sheets for the grease that you're using, look at the 4-ball EP weld measurements, the 4-ball weld scar, as well as the base oil viscosity. So this one, the higher viscosity of base oil, the better. The higher the 4-ball weld or EP weld, the better. And the lower number on the 4-ball scar is better when you're looking at comparing greases. Look for your temperatures as well. That's always a key thing. So I usually take a reading with a barometer on the bearing shaft just to get an idea as far as how much that particular unit's running, what temperatures. So you'll know your application needs. When down below, the oil and it's oil lubricated but it's cooled by water circulation. A lot of these times you'll find that the EP mineral gear oils to be used. So make sure you look for your viscosity. Typically in this application, it's ISO 680. But a 4-ball weld EP value and the scar is also key components to look at because you're carrying a lot of load. And you've also got, running heat and everything like that in this particular application. So sometimes I'll run into customers that are using synthetics here. And the reason why is the water supply is contaminated. So the reducing of the cooling effect of that water isn't as efficient. And also in the cool climates, upper United States into Canada type thing, stability has been a bit beneficial. So a lot of people use a PAO synthetic oil. And then oil-only lubricated bearings, it can be either a PAO or a PAG. I typically use a PAG. It's a polyalkylene glycol synthetic oil. The additive pack in this thing doesn't kick in until about 170, 180 degrees. So that's well within the operation temperature of those particular applications. I'm going to hand this over to Jason because in their university, they actually have this stuff where they pick it apart. So Jason, if you want to kind of walk us through.
Yeah, so we have a kiln bearing right here, and this would be the water-cooled type. And as Carl was talking about, making sure your lubricant, your temperatures, and that, if your lubricant does require that cool down, that you're making sure your water system is flowing. It's just as much as an important lubricant to that roller as that actual lubrication inside there. So, here, as we were talking about, you'd have your water coming in and out. We go on the inside of the unit, and then you have your scoop right there, which would, rotate down in, scoop it up, pour it out, which would normally be a tray right here that we've pulled out for training purposes. But it would dump it on that tray, evenly disperse it across that shaft there, and help keep that lubricated. Now, the one thing that, Carl will talk about a little bit later, and as you can see on ours, for training purposes, we don't have nothing on the drains, but making sure you have a good sight glass on there where you can take samples can really help you out in getting the data that you need to keep your unit in top running shape.
Good job, guys.
Absolutely. One of the things I would add to that too is you guys that are running water for cooling, and this may obviously go without being said, but always checking your lines, making sure it's part of your PM program for calcium in the line, the buildup that causes restrictions, so you're not getting a full circulation through the bearing. Those are things to monitor, especially if your water, like in most places, is recirculated and coming back through is where you see a lot of that buildup.
Yeah. And if you got water in your oil, if you put I typically will use a hub system, and you've got a bowl that you can put on the bottom there. You can drain the oil from that, but you can also quickly visually see it without opening up the unit if you've got oil in or if you've got water in your oil. So it's a good visibility piece that we can add on there for reliability. So we'll be adding that on for future university classes and stuff like that, as far as how everything fits together. So it makes maintenance a lot easier and quicker as you're doing your weekly audits, if you will. Good job, Jason. So beautiful. All right. Severe conditions. These things are operating in one of those high heat and heavy loaded conditions. So the grease of the roll is under the constant attack. So look for your oxidation, your varnish, and your wear. Those are the key things that you're trying to apply here. So the key properties in your lubricants that you're looking for is oxidation resistance, resistance to heat and degradation, and your maximum wear protection, both in the EP values as well as the anti-wear values. All right, moving on to the thrust roller. These don't get used, all the time, but there's, if your unit's floated correctly, Buck will educate me on this one, probably everybody else as well. But it helps to keep in line, but these things should be running, constantly. It'll be touched every now and then if it's floated correctly, but they do operate on an angle. They run against the side of the tire, keep the kiln properly positioned. So when you need that lubricant, typically they're in a graphite block with a spring-loaded mechanism. So your choices here is the Molly block. This would be a good application for that one because they can be cut to size to fit the same applicator. Or if you don't have one of those and you're manually type of lubricating this now, or you're not lubricating it, You can also use a WBL52 in this application, just for an option for you guys.
Yeah, it's definitely another point. It's a metal to metal contact, and it's an area of wear that we have the ability to help reduce that wear and prolong those components. Your thrust rotors, excuse me, are really, if you think about them, are training wheels. When you learn to ride your bike, you didn't ride on one side or the other, and you got to the point where you were riding between those training wheels, and that's really the goal of the thrust rotor, is to keep the unit in a good thrust position, as close to neutral as it can be. If you're not lubricating, you should be. These things are very simple. I mean, you can look at the block there. The holder there is very simple application, but a very key component that needs to be lubricated as well.
Yeah. You can see it rides on the side of the tire as well. So, excellent. All right. Let's get into the fun stuff. Let's talk about bearings. This is, we all see them and work with them. So if you don't know what the design looks like, we put a nice little pretty picture up here so you can see the inner and outer races. Jason has been kind enough to take theirs apart there at the school. This is what you don't want a bearing to look like. So, but it's got a good coating of grease. Yeah. We usually like to see it in a little bit better shape, so we gave him a hard time earlier, but he did a great job. He goes, wait, this is what I'm trying to tell people what not to achieve. So I was like, nice recovery. But yeah, this will give you an idea as far as what the insides look like if you haven't ever taken one apart. There are slip types. There's, the base saddle that's holding the unit together. The journal and shaft is right there that you can see. So it's nice to see one in live where you touch and feel. So that's the benefits of going to the university. It's not only do you talk about it, but you can touch and feel and actually visually see everything and how it operates, which is a big benefit of the class. All right, and there's many types of bearing elements as well. We've got the single or dual ball. You got spherical ball, straight or tapered rollers, and then the needle or sleeve type. Nice shot there, Jason. Excellent. So just to give you an idea, I mean, these can be greased or oiled type of lubricated. So typically what we're looking there is the grease type.
Yeah, you'll find the grease type in those. A lot of you guys that have these kilns are you're going to have sleeve bearings where you're introducing a liquid, oil lubricant versus a grease in these roller type bearings.
Yep. Good point. And the oil here, the needle or sleeve type, you can see that little hole. I'm hoping on your presentations or on the slide, there's a little hole where the oil goes into to help spread the lubricant in there. All right. So in theory, and this is how we look at this particular thing, the ideal lubrication phase for these particular applications is no metal, no wear. So lubrication regimes, we call this hydrodynamic lubrication. So you got the bearing here, you've got the journal on the inside, and then you can see the wedge of lubricant. There's not much there, but that's what's protecting it. But notice there is not a metal-to-metal contact in between those things. So you're basically riding on the fluid film. So it's what we refer to as hydrodynamic lubrication applications here.
Carl, let me ask you this. So yeah. in that hydrodynamic state, what do you think? What would you consider the most important property of the lubricant to achieve that hydrodynamic state? Would that be viscosity?
Usually on this one. Yeah, good question. On this one's usually viscosity of the oil. So a lot of these things that you'll run into, you can range from an ISO 680, so it's a very thick fluid, but you've got a lot of weight, and it's a slow-moving, heavily loaded type of application. So you'll want a thicker fluid. Sometimes, if you don't have the cooling effect like you do in the 680 environment. A lot of people will use an ISO 1000, so it's even thicker. And I've also seen an ISO 1500 fluid, so it's even thicker than a 1000. And all that's doing is creating a, it's a real thick for high heat applications and heavily loaded. So these things are pretty huge when it comes to the bearings and stuff like that, so you need a thicker fluid. Good
Bigger
question.
isn't always better, right? I mean, we just don't want to go with the heaviest oil that we can get to try. We can actually go the other way and create heat with a higher viscosity, could we?
That's correct. And in this particular, these are heavily loaded units. So you wouldn't put an ISO 1000 or 1500 into an application where the speed of the bearing is actually moving quite fast. You'll end up causing all sorts of other damage because you can't compress a fluid. And the thicker the fluid, it won't be able to dissipate the heat that's been generated. It'll go in a way of itself with fluid friction. So you'll run into those two. I wouldn't put an ISO 1000 in a high-speed bearing. That's where you run a thinner fluid, so it'll dissipate, and you don't need a whole lot of lubricant there anyway. So, good question.
Are there any other questions?
So,
does anybody have any questions so far over what we've covered?
Nothing yet.
So cool. Also, if you guys want a sample of the liquid graphite type stuff, let us know. You can send your request through here through the questions as well. Or contact your IKD representative. I'll help support them because I'm usually the one pouring out the product. So, all right. So in this hydrodynamic lubrication, some of these rolling element bearings, they really do benefit from extreme pressure in anti-wear additives or the AWs, and even solid lubricants with the moly or the graphite. So in a graphical representation, if you look at the coefficient chart here, which is the very top one, at startup. So this is where a lot of your wear is created, because you've got close to, you're in boundary lubrication or you got metal-to-metal contact. So as you're starting it up, this is, without any EP, you've got a high wear rate or a high friction. So your EP or your anti-wear additives would be applicable here. So without, you've got a lot of wear, and then with the EP or anti-wear, you notice in the red, you don't have as much friction there because you've got a layer of lubricant protection. Then once you move into the mixed film lubrication, it's not as relevant, if you will, because you finally got away from the metal to metal or the asperities touching one another. So the mixed film, you got a little bit here and there. And then once you achieve the hydrodynamic lubrication, the EP or the anti-wear is really not all that important at that time. That's where fluid strength and the thickness or the viscosity of the oil comes into play. So if we move down to the film thickness, which is the second graph as far as the ideal. So when you first start up, there is no film because there's not any speed or any velocity, moving this thing. So, and with a minimal amount of viscosity there, you don't have much. But as the unit is moving from the boundary to the mix, you're finally getting that turbulence in there and film built up, and you're separating the metal surfaces away. So once you get past the mixed film, then you're back into the ideal thing for a hydrodynamic lubrication, which is what we're trying to achieve. And then the last one, this is the one I kind of focus on because this is where all your wear is at startup. So if you start at the very left, if you didn't have any EP or anti-wear additive, you're going to have high wear. And this is where the EP or the extreme pressure or the anti-wear additives really do play a big part. So if you notice in the red, with that layer of lubrication, you're protecting the metal surfaces. So in boundary lubrication, you've got the asperities touching one another. this is where the anti-wear and your EP additives really come into play, to where they're protecting all the way into the mixed film regime. So this is where viscosity and the EV additives are working together. And then from there, you know, once you walk into the hydrodynamic lubrication regime, that's where you've got the ideal thing there. So you've got viscosity, you've got the rotational speed, and you've got the load that are all key pieces here. So, but this is where the anti-wear and EP of your particular product is ideal. So on your startups or shutdowns, this is the things that we kind of look at. So when you're comparing your gear oils, look at those EP values, look at the anti-wear value as far as the wear scar, and also look at the viscosity, make sure you've got the right viscosity of oil in the application. Beck, you got anything on that one?
No, sir.
Darn. All right. Moving on. But if you've got any questions on this, or if you want to share this, just do remember we've got it as far as the handout section. And I think Bailey has put that on there for you all for ease of reference. So bearings, sometimes they're oil lubricated, such as enclosed gear cases. And typically in these environments, look at your environment, your temperature, your speed, your load, and look at the ISO rating or AGMA rating. Make sure you've got the right lubricant in those. You also have grease, you know, but grease is typically used where you've got slow moving mechanisms, extremely high loads. There may be shock that the unit actually sees for that particular thing. So they'll actually use grease to help that shock value. And then if you have a gearbox that does your frequent stops and starts, grease is typically used in those applications. So you keep the lubricant in the application more frequently than what you do with the fluid. So let's go ahead and dive into the oil, because it's going to be the simplest. And this is the viscosity. These are industry standard type stuff, so there's nothing new here that I'm sharing. So if you haven't seen this before, hey, use this for a reference tool. But to give you an idea, this is how we kind of look at the applications. So look at the RPM of the unit, and then look how loaded it is. If it's a heavy load and you're not moving very fast, ISO 1000. Vice versa. If it's a light load and you're less than 50 RPMs, you can get away with using ISO 320. But look at the RPM speeds. You know, as they increase, the viscosity of the oil decreases. So the faster it goes, the more turbulence you have, the lighter the oil that you want to use. So if you guys have any questions about that one, you know, feel free to ask. Other than that, that's pretty standard information. And it's a nice, easy reference tool as well. So let's dive into the grease, because this is where a lot of people love to go play, because we don't know a whole lot about it and how they work. So we're going to go into some basic type stuff. So using the correct grease, very, very, very key. Look at your temperatures. You're going to also need EP type of values on this one. So your extreme pressure grease is used in most of these applications. And please avoid mixing thickeners unless necessitated, because you're changing out from one product to another. Follow the purging procedures. And if you have any kind of questions about the purging procedures, please ask us, and we'll answer that on a separate basis. We can help you out there too. But big key thing is clean the grease fitting both pre and post. If you're not using a grease cap, this would be a really good time to start using them. And you can also get those in different color coding, so you don't have mixing of different greases. You can avoid that. And then, you know, as your system auto lube, you know, keep the bearing at 90% or 90 degrees point of possible. You know, it's closest to the loaded zone. So in this represent, you know, I wanted to put this picture on here as part of the diagram. This re-grease zone here, the 180 degrees to 270, your grease point at 90 degree point, that 270 mark, because of the rotation of this particular one, that's where you want to put, you know, apply your grease. That's the key thing here. It's not at the very top. It's not at the sides, but this is if you can, it depends on the unit as well. I get that. Some of these things are difficult to get to, but that's actually the perfect place to get your grease point, because you're putting all fresh grease in there, and then use your vents and stuff like that to, so you don't over grease. But this is where you're applying new grease that's 100% performance. It can help get some of the contaminants out of there as well. But that's, the preferred method, if you will, as far as where to put the grease fittings. And then methods for lubricating greasy or lubricating the bearings. All right. So let's, it's probably easier to do this one. Here's what not to do. Pump a random small amount of grease into a bearing. We go through this, sometimes you walk through the plant and you see the guy just walking through the plant, randomly finding stuff and just wants to act like he's staying busy, so he's greasing a fitting. Hopefully that's not being practiced, but please don't. That's not what to do. Or you come back from a schedule or worse random time and you're doing the same kind of route and you're just randomly greasing. Pick a spot, find out where you stop, and then start at the next one. Just be aware of what you're doing, basically, so you don't want to over grease. But and you keep repeating these things, you're going to end up with these particular situations. You got your dried up grease accumulates inside the bearings, especially on the opposite of the lube inlet. So basically, what happens when that does occur, this is where a lot of over greasing comes into play, because as you continue to pump in grease and it's dried up on the lube inlet, or the opposite of it, it can't go anywhere. So where does it go? Usually where the seal is, and that's where you start blowing seals, and that's where you start using a lot more grease, because you don't have grease in there because it's going through the seal. That's what we find out a lot. The majority of the time of the applications, we see over greasing, not under greasing. So just a heads up. And we'll go through how much to grease as well later on in the presentation, just in case. But old grease oxidizes and it hardens, so it doesn't do you any good. It actually retains heat when it does harden, so that's where the heat builds up, and that's where the bearings fail. And they fail due to the heat, or on the flip side of it, because you've got all this dried up grease in there, the new grease can't get in. So you've got lack of proper lubrication, because 80 to 90% of the grease is actually the oil. The soap thickener and the additive pack or make up the rest of it, which isn't much.
Yeah, to that point, one of the things I read from Dodge was that the largest, to your point, Carl, was the largest reason for failure that they've seen is from over greasing.
Yeah. And a lot of this is just, sometimes it's just ignorance. I'm not going to call it stupidity, because it's just a matter of us learning, how to, and not everybody knows how to. I've been in this business for 18 to 20 years now, and I still learn every day. But I've got the basics down. But share knowledge. Don't tell people how to do things. Just kind of share the knowledge of, hey, this is how I usually approach these things, and I know how to grease, or how much often, or best approach. And we'll go through some ideas. We're going to share that knowledge today. So take it for, with a grain of salt if you want to. But these are pretty common practice type things to help get you pointed in the right direction. But, the following 4 practices will increase bearing operation, our operating temperature. So if you pump, if you're pumping too much lubricant too fast, that'll increase the operating temperature. If you fail to allow the excess grease out to vent out, you've got too much grease there. It's actually becomes an insulator. So you're insulating all the heat inside, which is not good. And then using a grease with too much of a high base oil. If you've got high-speed bearings, remember, lower base oil viscosity in those high-speed bearings, not the higher. So just to keep that particular thing straight. High-speed uses thinner oil. Also, if you're using a very soft grease, so if you guys are using automatic lubricators, you're using a single aught or double aught in an automatic lubricator, in let's say the the cold elements, and then you start getting into the warmer season, it may be too fluid for that application now. So you need to move up to an NLGI 1 or even possibly a 2. So you'll end up causing churning of the product inside, which is not good. Also, the use of the soap type may not be best recommended for the application. So the soap thickener that is used in the grease react differently under various conditions. So if you got chemical attack, water, all these things to consider. Some of the soap thickeners are protector against those applications. So just kind of be aware of those situations. And if you don't know, and you got one of those bearings that give you a lot of grief, give us a call. We'll kind of walk you through, just ask you some questions, and maybe we can help out. So lubrication procedures, the wrong way. Not enough grease is being delivered. Okay. Applied or injected through static condition, the new lube will tend to cut a path through the old and displace only a small amount of the old material. And this is just another thing that we see out there. The old or perhaps the wrong grease soap thickener is not sufficiently displaced, so it builds up and it dries out on the inside. That leads into higher heat that's being generated, and then the heat actually breaks down the bearing. So the right way, select the best soap type for the application. Typically, your lithium complexes are very commonly used, and they have a wide range. But your calcium sulfonate greases are higher chemical as well as water resistance. So that might be an advocate application to take. If it's food grade application, sometimes you'll run into aluminum complexes or calcium sulfonates in that. So depending on what you run into in your application, the soap type does play a key contributor as far as selection for the grease. Make sure that the bearing is flushed with adequate amount of new grease. Also, the right way, bearing is properly vented, so it permits the excess the grease to escape in order to prevent the seal damage. I'll have to go back and do my change my word there. The bearing is also maintained with fresh lubricant, preventing overheating and displacing contaminants. And then make sure the bearing is greased during operation or just prior to operating. So that's the best time to actually apply the grease. All right, check out any questions. Man, you guys are good, all knowledgeable. So I find these things all the time. And in defense of the maintenance guys, I get why they use the battery operated, but I'm not a fan of them. But I'm not the one sitting there greasing all these things throughout the plant. So I do understand the need, but they can be used, but it's not preferred. I usually, you got to take an extra battery pack. You got a number of points to being serviced. Make sure they're calibrated. Know how much grease you're displacing out there. I've talked to a couple of maintenance guys that had these, and they've got their grease routes, of course. And I asked the one guy, well, how many shots do you put in this thing? Oh, I go until I hear the difference in the whine of the motor. And then you look at the bearing that he's greasing, and it's got grease coming out of the seal, and it's all over the place. So again, over greasing, it's just a matter of just educating. When that particular bearing, after we went through the exercise, only needed to be greased once every 4 months, and he was doing this every week. So this is what we're kind of going through.
And sometimes it's just a cultural change and those are the hardest things to do, right? Is to change the culture, because we're just so used to this is the way we've always done it. And that goes, on down the line. But very important. I mean, I understand the feeling on the electric, but I think it's really critical to understand if you're using either electric or manual, is to understand what it is. What does one shot? What does one pump? What does that mean? To understand what the amount is, and the frequency. Those are very important to know without it just being some random number, 5 pumps is what it takes, without understanding what does 5 pumps represent? What exactly are we putting into that?
Yeah, and we'll go through that too. A lot of these things on the units, you can have a color-coded grease cap. You can also number these things too, and the number could be weekly, monthly, that type of thing too. Just know you got that capability of when you do label these things through the oil safe system and color-coded type stuff. You've got that capability of knowing when and how often you need to grease that particular bearing. So the hand ones, I like them because you can actually, you can feel the back pressure, and you know when to, not put any more grease in there. And they're lighter to carry around. There's no spare parts. There's no extra batteries to carry. So, that's one thing. But if you got several hundreds that you're doing in a route, I can see where that would get old really fast. Or, if you need arm strength, that's good. This is a pistol grip version as far as a manual. But there's also the lever version, which I prefer over that one. But the best method for lubrication is auto lube system. The lubricant is, lubrication is automatic, and it takes less labor and time. You can manage the system versus managing the individual grease application. Lubrication frequency can be accelerated if you needed to, or decelerated. I need to put that on there, but to give you an idea, this is where you can go up and down. Less potential for contamination. So when you're plugging and playing, changing out kegs or your individual cartridges, when you do the individual cartridges, the more you touch and are exposed, the more potential for contamination. The auto lube systems help minimize that. And also the contaminants are being purged more frequently. And what's nice is if you're doing weekly manual type of lubrication, you got your peaks and valleys, and I wanted to represent that in the blue line here. So as the unit's running, you'll go in there, you grease it, on Monday, and then as it goes through, you get to a certain level where you've got a little protection, so you got higher friction and higher wear, and then the next Monday you come back, you put more grease in there, you spike it up where you're almost over greasing, and you let it kind of slowly trickle down. With the automated lubrication, you can take the same value of what you need to lubricate on monthly and just reduce the amount, but increase the frequency. That's where you get this little white line here where you got the optimal way of greasing. So just something to consider, and you can achieve that through a single point auto lubricator or a multi-system, which is pictured over here to your right. And then also Jason's got the open gear system. Those particular things are automated type of lubricant systems. These all help out. It's much easier to manage this system versus doing the actual lubrication manually. So just to kind of touch on that one. And then procedures for different types of bearing houses. Let's kind of dive into this one real quick, because you've got a fill plug and a drain plug. With this one, let's see, I thought I had one right before. I don't. All right, so you've got the seal bearings, which I think I put in here. There we go. So I love this one. There's no lubrication required because you've got seal bearing. So maintenance is easy. But I'm gonna go back. This is what we find a lot of. This is where you've got a fill plug and a drain plug. So how do you do all this? Here's the procedures. Of course, you remove the drain plug. Now, this is grease, this is not oil. So don't think that when you open this thing up, you're going to have all this oil gushing out at you. It might be thinned out grease, and it might be a little runny, but it's not going to be like oil running out. If it is, you got a major issue going on. But for most part, for grease, you can let it'll come out just a little bit, just because 80% of the grease is oil. But it shouldn't be flowing out like an oil or fluid. But make sure the drain hole isn't clogged, after you take the plug off. Wipe your grease clean on the fill plug before you hook up with your grease gun. That way you're trying your best to remove any kind of contamination that you're going to push into the bearing. So that's the reason why we wipe it off as best as you can. Some people spray stuff as far as the chemical because they want to cut through the grease. Just remember that chemical is going to be added in there. And when you push the grease, you're pushing that chemical and that grease in there. So either grease needs to protect and get rid of that chemical, or you're kind of adding more stuff in there. So if you can, I just wipe it with a clean rag as best as you can. Or if you got a rag that you're using for the whole plant or the whole route that you're using, start using a section of the rag that's cleanest and work it that way. That way you're not replacing too many rags. But when you do this, pump slowly. Don't go in there just kind of, do the force fit because you're trying to get out and, get home, faster, or get to lunch, or, take your time, do this right. It'll pay off in the long run. So you don't have to go back and, do the repair work on it. But you pump this slowly until the grease is seen coming out of the drain plug, and that should be the new stuff. Or if you're just filling up, you'll see where it's coming out. Wait a few minutes so you allow a little bit of the excess lube to be displaced before you install that drain plug, because you don't want to fill up the entire cavity of this thing. That's it's a key. Grease is actually an insulator, so you want this thing about 50 to 40% full. That's that's the sweet spot on this one, and that's where you want them to roll. You don't want it, 70 to 80% full, because the grease isn't going to be able to displace the heat as fast, and you're going to be running that bearing a lot hotter than what it should be. So, any questions? Buck, Fox, what have you seen?
Oh, agree. Yes, sir.
You're being too easy today. All right, let's go. So this one I like. It's sealed. If you're a lubricant sales guy, you don't like these things, but I like them just because of ease of maintenance. So it's a love-hate relationship. You'll find a lot of these in your electric motors and stuff like that. So it's commonly found. So there's not a grease zerk. So that's a high indication that there's not any application for that to apply grease to. So just FYI there. All right. So bearings without a drain plug. Well, what do you do then? So I put questions in here, but I also have a benefit for you all attending. We put the answers in here as well. So we often do come across these examples of poor points. Here's the thing, the lack of venting for this thing. What's wrong with this picture? All right, so if you can see the two bearing lines here, I'm not sure if my pointer will work, but we'll give it a try. Laser pointer, here we go. So this right here is the grease line. And then over here is also a grease line. This one's at the top, and this one's at the bottom. So the question is, which one is being lubed correctly? Is it the bottom one, or is it the top one? So I'm going to poke your memory on this one. If you remember going back and we were discussing the hydrodynamic boundary lubrication, where the shaft is rotating in this direction right here, and the shaft over here most likely is over here rotating. You wanted the lube point on the bottom, because this is where most of your boundary lubrication, or where most of this is where the journal's rotating. So just to give you a heads up, so if you apply it, that lubricant here, you're getting fresh stuff right before this lubrication point where you need it the most. So correct answer is at the bottom. So this one, if they can, we need to move it down to here. And this is probably their vent or their drain plug that they're using for right now. I'm not sure, but this line should be moved down here. So do you see a vent on either one of these? Question is no, if they're not. So we need to install one. And then where should we install it? It's either the 3 o'clock position or the 9 o'clock position. Because you want the grease about half full. You don't want to, you don't want to put the vent all the way up here, because as you're filling this thing up, the only way that you're going to know when to stop is, when it finally starts purging right here. You want to purge right in this area right here, where it's about half full. So hopefully that'll help out and give you guys some ideas there. All right. What kind of, ensure the bearing is properly vented. So these are a couple pictures of the vent available through OilSafe and IKD. Let's purge this, during the greases. Even though the bearing was purged during greasing. Yeah, go ahead.
We do have a question. They asked if the top bearing lube or the bottom bearing lube are 270 degrees.
I'd have to take a reading. I don't know what the temperature was. Or are they talking about the actual degree? Let me go back.
I think he's talking about, yeah. He's talking about in the radius there.
Yeah, the radius. So this would be at the 270 degree mark. Because this is probably where your lube point is, and then back over here is about 270. So that would be the ideal area. This one I hear, your bearing is probably, your zeros here. They could probably move this one over here if they really wanted to get the more of the 270 mark. Good question. Hopefully I answered it. So if I did, feel free to continue ask them. Appreciate it. All right, so even though the bearing was purged during greasing, there can be an expansion of lubricant during the operation, and it can be caused by buildup of contamination. Maybe you got excessive heat causing the lubricant expansion, or maybe they're running the unit faster, so there's too much speed. And sometimes you'll change greases, and you're working with an ISO, a base flow to basically 108, an ISO 180, and you switch it to an ISO 460. It's a real thick oil versus a real thin oil, depending on the suit. And that could also, if you're running the same speed or too much speed, you'll definitely tell the difference between those two. The ISO 180 will actually cool faster. The 460 will not, but look at the load as well. So these are all factors that we kind of take a look into, selecting the grease.
Hey,
but
Carl.
also, yes.
He followed up and said he was talking about the location of the ZERT.
Okay, good deal. Let me go back. So on this one, the ZERT here, that would be the proper, so your 270 degree would be the proper location on this one. So what you're doing is you're putting the ZERT here, and then your vent will either be over here at 9 o'clock or at the 3 o'clock position. So once you start pumping grease up to this point, if these are grease, then this is the level that you want to have grease applied. So once you start pumping in grease and you see grease coming out, either vent on this side or on this side, you can stop adding grease. And then it's properly level, and then we'll go into how often, how frequently you need to replenish that grease as well later in the presentation. So on this one, if I were to change this one out, I'd take this lube fitting down here. I'd probably plug this one and move this one over just a little bit. Give it a little bit more time because your 0 point degree is probably right in here. So it'd give you about 90 degrees to work with. So by the time you put in the lubricant here, and then I would add a vent either at the 9 o'clock or at the 3 o'clock position. Hopefully that answers. If not, keep asking away. We'll get to it. All right, so what you're going to run into on the venting. We see the pipe elbows used as a vent port fitting, but the preferred vise is a spring and ball effect. And these are all available through IKD, through the OilSafe system. So. Then, here we go. How much grease do we actually put into this thing, and what's the right amount? So there's ways of doing this. You can use a sonic sensor, which some people can buy these things, and others may not have a budget for them because they're not cheap, but you also need to be trained on how to use it and what to listen for. But it's a great tool to optimize how often, the lubricant needs to be greased for your application specifically. But you can distinguish a dry bearing, a well-greased bearing, an over-greased one. So a lot of good things that you can capture using this particular sonic sensor. If you don't have one of those little tools, well, what do you do? All right, let's go back to simple math. So there's an industry standard chart. So it's real simple. Look at the operating speeds as far as the RPM, and then you measure the shaft size. And this chart's pretty nice because they give you not only inches right over here, but they also give you the millimeters. So if you're working with metric, it's a quick reference guide. And then here's your operating speeds as far as your shaft. So 1500 RPMs, and then the shaft sizes of 2 come all the way down here. You only need to lubricate that thing 2 months or every 2 months, not much. So that tells you how often. Let's go ahead and go over here. So now the quantity. Real easy math. When we typically reference the Lincoln SKF formula. It's a tried and true, if you will. So they use the volume of grease to be replaced every 8 hours. So they usually take the diameter of the shaft, or the shaft diameter, and the number of rows, and then you usually put that into ounces, or you can put that into the metric. And just as an example, here's what you got. Here's your bearing size, and there's 2 rows, so 8 inches and 2 rows here. So you multiply that, so D2. So here's the formula here. So your diameter twice, and you multiply that times your number of rows. And to convert this into cubic inches is this, which is converted into 0.15 ounces, and that's applied every 8 hours. So in the metric and as far as conversions, you still use the same diameter. So 8 times 8, that's your D2. So your diameter squared, multiplied times your rows, multiplied times 0.002. And then this is your conversion factor to get you in milliliters. So 4.2 milliliters every 8 hours. That's not much. So if you think about it, that's an 8-inch diameter shaft. And you only need this little itty bitty lubricant of grease in 8 hours. Now, on the flip side of it, do you want to go over that unit and re-grease every 8 hours? This is where the single point lubricator or multi-point lubricator really comes into play. But so how much do we put in here? All right, so we know how much, but we were talking about, well, okay, my grease gun, how much does it output? And then how many strokes is needed? I've got one guy over here using battery operated. He just listens to the number of clicks or waits till the motor lines to know when to turn it off. He had really no idea how much grease he's putting in the bearing. So typically with a high volume, but yet a low pressure grease gun, they deliver about 1 ounce, which is 28 milliliters per 9 strokes. Or that's also equivalent to 0.11 fluid ounces, or 3.12 milliliters per 1 full stroke of the handle. So that's the handle grease gun or your other one. So just kind of give you an idea as far as how much grease is coming out of that grease gun. The high pressure guns, this is the 7,000 PSI, sometimes they go up to 10,000. They deliver 1 ounce per 25 strokes. Or if you need to put that in fluid ounces, 0.04 or 1.12 milliliters per 1 full stroke of the handle. So this is where injectors and metering valves also have different adjustable. They're even adjustable, so their output volumes, the formula is not difficult to run, so you can set your automatic lubricator to match this. And if you're going to do the automatic lubricator, do smaller amounts more frequently, so you can keep that nice white line as far as optimal lubrication. So these are things that we can help you out with. But this will give you an idea of, I'm going to go back here. So this is what we determine how often. This is determining how much, and then this determines how many of these strokes, how often, and how much. So it all ties in together. So it's a lot of mental work. And then after you do this, write this stuff down so you know you don't have to go back and recalculate these things over and over again. Or if you change out, you go from a Dodge to some other, SKF, and they're not the same kind of bearing and application, you're gonna have to make a new set of notes because not all brands are equal.
Great.
So just keep your notes as much as you can on that. Just make it easy on your life. Agreed?
Agreed.
All right. So grease quantity, and this is just another example, but this is where we're going into more details. Shaft diameter, again, you've got your rows, and then your cubic inches. But this is the example. We just step by step, exactly how we kind of figure it out. So for your gun that's delivering this is what you need, and this is what's coming out of the gun per stroke. Guess what? You only need 1.4 or 2 strokes of grease every 8 hours. So you're going to go over there every 8 hours and do 1 and kind of have a half or 2 strokes. I don't know how technical you guys are, but that would drive me nuts. So if you run into this, definitely use an automatic lubricator. And then this will be the metric version, if you will, of the same kind of thing. So where you wanted 4.2 milliliters. So here's 4.2 milliliters that's needed for the application. Here's what's coming out of the grease gun. So you only need 1.4 or 2 strokes of grease every 8 hours. But now you've got the numbers and metric as well as So under these particular ones, you'll probably need to lubricate a little bit more often. So if you do have high and or shock loads in the application, you'll probably need to grease a little bit more often. High vibration, eccentric motion, when there's presence of water and chemical attack. So if your bearings, exposed to that type of thing, you might have to replenish it with grease a little bit more frequently, depending on how the grease is resistant to that particular application. Also, when there's a vertical shaft involved, you'll probably need to grease more frequently as well, just because of gravity. And then also, if you're walking into an environment and you inherited a bad area where it's got 4 seals, and you're not close to an outage, this is where you're going to come into play, where you're going to have to grease a little bit more frequently until you can get to that planned outage and fix the seals. And then elevated environmental temperatures. If you're working in a hot area and it's a heat generating machine, guess what? Your temperatures are going up to an extreme. So I'll look at your grease performance temperatures first operating. And then with greasing techniques, you can probably get higher temperatures if you replenish the grease more frequently. So just a cool little practice that we can share with you guys.
One thing else, I look at how often startups and shutdowns of that are used or those bearings.
Absolutely. Good point. Cool. So that kind of gives you a general feel for that one. Then we're going to step into the oil-safe world of color coding. A lot more plants are using this and utilizing it. They've seen the benefits of it. And I've always recommended this in my past, but now I get to sell it because I'm the manufacturer rep. So that's kind of fun. In IKD, we do free audits and stuff like that. It's where the Whitmore team comes out and supports them if you guys are interested. We'll do a whole customized type thing and implementation plan. It's not just you buy the product and you're done. We can help out with, all right, we don't have anything or we got something and we're working towards it. We can help you no matter what phase that you are in implementation, or even you've got a clean sheet of paper. Where do I start? We can kind of help, ask a few questions and kind of guide you on what best fits your application and your efforts. Just for a keynote on this one, you'd be surprised about this, but you don't start at the big bulk system. I always thought you bought the big bulk system and then you bought all the piddly stuff afterwards. It's actually opposite. It was really kind of interesting to learn this, but you start identifying the loop points on the assets first, because that's where all the errors are being made. And it's nobody's fault, if you will, because we all make mistakes. We're human, but this is where the wrong grease is being applied in the application, or the wrong oil, wrong viscosity of oil. It's not on purpose. Accidents do happen, but what if I've got a customer that's not familiar with my plant, we walk up to the gearbox and you don't know what's in there. Well, I'm new to the plant and the temporary, I don't know what product goes into that application. But the guy over there maintenance said, pour this jug into that. Well, what if it was the wrong jug that I grabbed and I put the wrong oil in there? This helps eliminate all those communication things. So, and if there is colorblind type of people at the plant, which I even have family members that are colorblind, the reason for the shapes is if they can't see the color, they can certainly see the shape. So I learned that one as well. Didn't have an idea as far as why until I came up, started working with the company. And then the transfer fluid containers. These things are robust and stout. There's some cheaply made versions out there, and when you drop it, it falls apart. These things are pretty indestructible. So, excuse me. They do get dirty, so you can always clean them off on the outside, but just understand that they're pretty robust. I do like the labels on them. The tags and stuff like that usually get in the way. So if you can write on there, what the brand is, color, and then have the shape on there, you should be good to go. And OilSafe also offers those. They're self-adhesive type of labels, but there's different varieties for different applications and different, if you've got a certain way you want to do things, great. And then the system. So you've done all this work as far as identifying stuff on the asset. You've got the right kind of fluid in the containers. The system's the last thing that you usually do. And that, they're not the cheapest ones on the market, but there's fire safety in there. There's electrical safety that's already built into these things. Each of those tanks have a dedicated pump and electrical outlet. So if there is something wrong, only that one needs to be shut down. But you will never have any kind of cross-contamination if you hook it up right. So it's very clean. I do know when a lot of people buy these units, the attitude of the maintenance personnel really starts shining. Sense of pride really comes into play. These things last a long time. So when you buy this, it will last probably longer than I'll be alive. So it's a great practice, great thing to do. If you haven't already implemented it, I would highly encourage it. It really does enhance your reliability practices at the plant.
Well, and it's also, a morale spike for the maintenance guys when they start seeing how easy it is. It gets really efficient and some. Yeah, and one key thing, just to share with everybody, I've been in lubricant sales for quite some time. Just know, new oil is not exactly clean. We all assume it is. It's been filtered. It has a certain ISO cleanliness level. Well, guess what? The only person that has the say in handling and managing the cleanliness is the people at the plant. And you can go back to this particular slide. Using this particular system and this method will help not only filter, because you got three-way filtration on this one. You filter oil going into the tanks. You can do kidney loop, and you can filter coming out. So it's a great way of managing and filtering your oil as you receive it into the plant, because you are the last line of defense. And then if you got contaminated lubricants, you're already hurting yourself as far as you're putting bad oil or dirty oil into a unit that you actually thought was clean oil. So you guys have the last say in the matter. So I really do like that kind of control. As far as, at the plant level, you can request your distributor to bring in filtered oil
and they're going to charge you extra for it, you know, when you can actually do this yourself and control your cleanliness of the lubricants. And I shared this from, you know, I captured this from one of my distributors I work with him quite a bit. I learned from him, he learns from me, so we like to share information. But if you've got trunnion bearing oil, we've got the capability of taking what was in there before and then cleaning it just like this. And here's the system that we were talking about with Jason showing the trunnion bearing. This is that hub system. Here's your little bowl that you can see water if you do have water in your oil. And here's a color-coded quick connect. And this would attach to, here's your oil here. Notice the red for the color coding, same label. And here's your color-coded quick connect that would go on to that assembly. And then here's your sample port that you can, you know, take samples consistently. So as you can see, this sample, we still haven't quite gotten to the cleanliness level that we wanted to achieve. But when we were all said and done, this was the result. And it's really nicely done. One thing, a caution of error. This particular tube is acrylic. If you're using a polyalkylene glycol synthetic oil, it will shatter this thing. It'll crack it up. So I would use a glass type for the sight tube. That's one thing that I did, that we learned during that whole exercise. And then if you got some smaller gearboxes, you got the same kind of capability of just having a visual sight reference. This is where the magnet and also the rust, if you do have rust in there, this is you can unscrew this just a little bit. There's an O-ring there where it will not leak. So you can rotate this over. So you can actually turn this side, take the magnet out of this one, rotate it up here, and then you can test for if you got water in your oil. So, and then your sampling port will remain there, and that provides you consistent sampling. So you can build a true representation as far as trend analysis. A lot of times, if you're not doing oil sampling from a same point or lubricant point, and you got different people taking samples, they will all go in different spots to take samples. This helps eliminate this one because you've got the one port to pull from. So it's a really good practice, and it's starting to be standardized more and more so. And here's a picture of the magnet of what it picked up as far as metal shavings. And that's this little thing right here that's floating in the oil. Great tool, and it makes it easy, and you never open up the box. So you never, you know, open up the gear oil or the hydraulic reservoir. When you do open it up, you accidentally, you know, enhance the potential of adding more contaminants, which is something that you don't want to do. So this is really nice where it's a visual inspection, you walk by and keep moving. Going back to the grease fittings and your color coding type labels. So these are the caps that you can put over the grease zerks. So this will help reduce the amount that you have to clean, but you still need to wipe them off and everything. But it'll be color coded, and that could be by the type of grease. And you can put a number up here, which is a little white label, and it can be a different number. It could be a letter. It could be something like that. And that could be represented by here. So this one, we're using a red, and it's a square, so you'll know what type of grease. And then this is the frequency. So this only needs to be greased every 4 months. Or this could be, you know, 4 times, you know, it all depends on how you guys want to build your system. It's that flexible. But this will give you an idea as far as some of the applications. This one, you know, if you got the area to work with where you can go on some kind of a stand and you need visibility, a great way to doing that. And this one's just a little dangler. But I typically would use these with this type of system right here. That way it's a low profile, easy to get to, and doesn't take up a whole lot of space. Well, let me go back to this one. If you got a really big unit and it's got several grease points, this number system could go 1 through whatever. So if you decide to go take a break or lunchtime comes around and you got up to point number 9 and there's 21 points, you know, when you come back from lunch, you start at point 10 and then go to, all the way up to 21. So it could be, you know, just a numbering system on that asset. So just another idea to share with you guys. Desiccant breathers. If you're not using them on gearboxes and hydraulic reservoirs, please consider them. These things will keep the moisture out as well as the particulates in the air that are floating around. And we all know, working in our industries, we've always got something floating around, and we've got high humidity type of areas. We manufacture Air Centric, and the Guardian series right here is probably the longest lasting one there. It's got valves on the bottom and exhaust ports. It's got 4 of them up here for the intake. So the air will come in here, go through the desiccant. So you've got the particulates where you got a stainless steel mesh here. They'll handle the particulates as far as physical. The air will go through here, and the moisture will be taken out of it, going into either the drum, hydraulic reservoir, or gearbox. So if you put this thing on a gearbox or hydraulic reservoir, and you've got it to where it's expanding and exhausting, well, our patented type of desiccant breather, there's basically a silicone cover here that will plug this thing up where air cannot go back up in here, and this is where your money's being spent, is the desiccant breather here. So these will open up, and the air will exhaust. So as this thing is exhausting, it'll come right through out here. They've got 4 of them to come through. They can handle up to 750 CFM, which is quite extensive. Intake-wise, it can handle about 25 CFM. So this is the only one that's rated that you can put on a diesel fuel tank. So if you've got moisture in your diesel fuel, or you're getting sand in your diesel fuel tank, putting 1 or 2 of these on there may help minimize that contamination. But majority, like I see here, that's pictured here, we still have vents. Just understand, using this vent, it's allowing all of the air to come into it and all the moisture to come into it. There's not really, it's kind of defeats the purpose. What is it protecting against? Probably getting rain, directly into the gearbox is all it's really doing right now. So this is a good application for your desiccant breathers. And this is a primary, because if you see here, it looks like it's got a heat shield. So just watch your temperatures. If they're 150 degrees or more, I would definitely put a heat shield so you can use one of these. I think that's almost it. There we go. So you guys have any questions, or if you want samples of the WBL52 graphite solution, where you can, we'll send you out a concentrated thing. We can either do the demo for you, or we can send a sample to you, but we're happy to do that. So go ahead and feel free to reach out to either contact at industrialkennel.com, but as Jason was put on here, you guys are essential business, and so is IKD and Whitmore. So we're also open, and we're ready to help when you need us.
And we'd prefer to come out and see you rather than just mail it to you. We'd like to come out and visit with you, make sure we get the application rate and right. So let me know if you'd like a sample. Does anybody have any questions?
We have no questions on here, guys. We only had the 2. So apparently y'all explained everything, and it made everybody a little bit smarter today.
That's right. We're talking to a lot of smart people.
We hope, but hey, if there's any techniques you guys want to share that we can also add to our presentation, let us know. Glad to add it and give you guys credit for it as well. So we're not perfect, and we're constantly learning. So by doing this, we're sharing information that we know that has been tried and proven, that has been successful thus far, but we know that there's always other ways. So really appreciate your time, and hope we all learned something today. Appreciate it.
Again, if there's anything we can do for you guys, please let us know for your time, and I look forward to seeing and talking to you soon.
Thank you, everyone.
Cool. Thank you.